So when you don't see a base, that means that the base is what? 10. So if you have 10 to the power of a log that has the same base, a log and an exponent cancel. So you're left with just 7. Another way to look at that would be, but no, that's the easiest way to look at it. We'll just leave it that way. For number 2, same thing. We have a base 5 and an exponent of 5. So what's going to happen to these two? So what do you think the answer is going to be? Not log 12, just 12. Yeah, because the log goes away and so does the 5. So another way to look at that would be, if you move this to the front, you have 12 times log base 5 of 5. So what this is saying is 5 to the what power is going to give you 5. So we know that this parentheses is really equal to 1. And 12 times 1 is 12. So that's the street way. The highway would be to just know that a log 5 and an exponent of 5 is going to cancel. And it's just going to give you 12. So that's 2 different ways to work through that. All right, that's the first 3 questions in homework 20. It's just canceling out. All right, let's look at number 3, where you have to expand. The first thing you want to do when you're expanding is look for a fraction. If you have a fraction, how do you expand a fraction? With what? So that's the first thing I'm going to do, is expand and put this minus the denominator. That's what I'm going to do first. So that would be log base 7 of 3x squared minus log base 7 of 8. And then we have the 3 and the x squared that are together. So this needs to be broken up. And how do you break up multiplication? With addition. So I'm going to break that apart to log base 7 3 plus log base 7 x squared minus the log base 7 8. All right, last step. What else do I have to do? Move the 2. If you have an exponent, it gets moved to the front. So your final answer would be log base 7 3 plus 2 times the log base 7 x minus the log base 7 8. And that would be fully expanded. Any questions about that? All right. So now we're going to start 5.6. 5.6 is exponential and log equations. This is homework 21 and it's due on Friday. So this is due this Friday. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13 questions. Joshua, what are you doing? Can you put that away? If you in class, you might as well, listen. Just saying. Okay. So this is the easy one. Let's go ahead and do this one. So we're going to start off with exponential equations that don't require a log. If you can rewrite the base with a common base, you don't need a log. Can I use a common base for 4 and 2? All right, so what am I going to rewrite? 4 is what? 2 squared. So let's do that. So that would be 2 squared x equals 2 to the power of x plus 4. That cancels. Go ahead and solve this for x. So this is just a one-step equation. All we got to do is subtract the x. And we got 2x minus x, which is x. And our answer would be x equals 4. Who got that? All right, so that's if we can rewrite it with a common base. But what if we can't? So go ahead and copy down. We'll just do one at a time. So we'll start off with this one. We're going to solve for x.
Okay, I have an idea. But you gotta hear me out.
In the end, well, let me finish this and then I'll listen to your idea. So you always have to start by isolating the base because sometimes you can't tell if you can rewrite it if you don't isolate the base. So let's go ahead and get the base by itself. And when I say base, I'm talking about this term. We have to get that by itself because that's the base of your exponent. So how would you rewrite that? I mean, how would you isolate it? What would I have to do to get rid of that 5? Subtract the 5. And then I heard Marcus say, so that would be 16. And now we got 4 and 16. So can I rewrite that with a common base?
Yeah.
So 16 is the same as what? 4 to the power of 2. So your answer would just be x equals 2.
That was my idea.
Okay. All right, go ahead and copy down the next one if you haven't already. So again, you want to isolate that base, which would be this term right here. We have to get rid of that. I mean, get that by itself. So how do I eliminate that 6? What would I have to do to get rid of the 6? Subtract the 6. So now we have E. Now E and 5 cannot be rewritten with a common base. So we have to use a log. And we're going to use a natural log because a natural log has a base of E. You don't want to use a common log. You want to use a natural log. So when I put in a natural log, which I'm going to rewrite it, if I put in a log base E on both sides, let me go ahead and move that over. So if I put in a log base E, which is the same as a natural log, I'm just writing it this way. Because going back to the Bell work, what did we say would happen if the base of the log matches the base of the exponent? What happens to it? It cancels. This cancels out. This whole thing would go away. And then you would have 2x equals the natural log of 5. Remember, natural log is the same thing as log base E. And then the last step would be to divide both sides by 2. So your answer would be x equals the natural log of 5 divided by 2. Go ahead and type that in your calculator and round that to the thousands place. That means I want 3 numbers. All right, who got that? 0.805. I'm just writing down the answer so I know them for the next 2 classes. Any questions about how we did those 2? So if you can't rewrite it with a common base, that's when we need to introduce a log. All right, let's go ahead and copy down these 2. Now these 2 are pretty similar to what we did in the last unit though.
Oh, Miss Ryan, why
Yes.
did we not use, for the last one, why did we not put ln instead of log? Or why did we have flipped it and you said ln? Okay.
So I said that a natural log is a log base E. That's what it is.
Yeah, I
A
know
natural
that.
log is a log with a base E. So we need to figure out what this number is because this is a number. So 4 to the what power will give us 1 over 64.
Negative 4. Negative 3.
Is it negative 3 or negative 4?
Negative 3.
If you're not sure, type it in your calculator. Put 4 to the power negative 3 and see if that gives you 1 over 64. Do we agree it's negative 3? Okay. So now what do we have to do? Set that equal to, it's a quadratic, so we have to set it equal to 0. And now go ahead and factor that down.
Do we ever stop factoring?
No. Never. Like that was, if I would say going into college, if there's something that you should know how to do very, very well, it's factor.
I just thought we were done.
If that would be like the one thing I would tell anybody going into college is know how to factor. Because nobody's going to teach you. They expect you to know how to do that. And not only do they expect you to know how to do it, they expect you to be fast at it and to know when you're supposed to do it. Okay, so you need two numbers that multiply to give you 3 and add to negative 4. What would be your two numbers? Negative 1 and negative 3. Set them both equal to 0. So you would get x equals positive 1 and x equals positive 3.
When we gonna start graphing this?
We already graphed. We're done graphing. That was 5.4. Yeah, I think for the rest of the semester. Yeah, I don't think there's any more graphing. All right, let's go ahead and evaluate this and factor it. I think in that homework assignment you had questions like this. Did I put those in Skyward yet?
What?
No.
Okay, I need to put those in. All right, so 2 to the what power is 1 over 32. Negative 5. Set that equal to 0. Okay, so this one you cannot do a shortcut. So go ahead, find your two numbers that multiply to give you 10 and add to 7.
I know. 5 and 2.
Okay, good. All right, go ahead, finish taking out your GCFs. So when you solve both of those, you should get x equals negative 5 over 2 and x equals negative 1. Any questions about those first four? Pretty basic stuff. Good. Our test is next Thursday. Our Chapter 5 test is next Thursday. And then after Thanksgiving, I think we have a quiz, but I'm not even sure. We'll pretty much come back and start getting ready for the final. So this is your last big test before the final. So if you have a grade that you don't like, this is probably your last chance to make a big change to it before you go into the final. You know you want to go into the final with the best grade you can have because the final is 20%.
Do you drop the low score now?
No. We don't drop any tests because you all get retakes. So that's why we don't drop it. It's either A, offer retake, or B, drop a test. So in this class, we offer retakes. Okay, let's go ahead and copy down these next two. So now, notice that we have the log of a variable. So this is why I put this red box. I guess this would be my new red light. We don't really talk about this red light much, but now I'm introducing a new red light, and that's the log light. So I'll give you a minute to write that down. Logs have a restricted domain, which is why you have to check. So in the past, we just talked about 2 red lights. Now I'm adding a third one, and that's the log. Logs have a restricted domain, so we have to watch out for it. So when you see a log on both sides, we can cancel it. Log on both sides, cancel, and solve. Go ahead and solve that. But we have to check for extraneous, and I'll explain what that means here in a second. So we need to set that equal to 0. Subtract the x and subtract the 4. So that's going to give you 0 equals x squared minus x minus 6. So go ahead and factor that down. 2 numbers that multiply to give you -6. Add to -1, factor it, and solve them. So what would be your 2 numbers that multiply to give you -6, but add to a -1? -3 and what else? All right, so go ahead and set them both equal to 0. And we get that x could possibly equal 3 and x could possibly equal -2. All right, so everybody pick up the calculator. Pick up your calculator. I want you to type in log of 0. Log 0, what does it say? Domain error. Type in log -10. What does that tell you? When you take the log of a number, this is the new red light. So I got half of y'all listening, so I just need to make sure y'all paying attention. When you take the log of a number, it has to be the log has to be greater than 0. So that is a new red light that we have not talked about. So what that means is when you take these numbers, I want you to do a test, and it's not even a hard test. I just want you to test to see if you put a 3 right here in this first bubble. Is that going to be a positive number? 3 plus 4, does that work? Okay, what about over here? 3 squared minus 2, is that okay?
Yeah.
So that means we can keep the 3. You can keep it. So now let's do the same thing with -2. -2 plus 4. What's -2 plus 4?
Well, it is 2.
+2. So that's okay, right? Yeah. What about -2 squared minus 2? Yep. So this one, they both work. So we actually have 2 answers. Now I want you to be careful because they don't always work. That's the red light you have to check for. All right, let's look for this next one. Do we have a log on both sides?
No.
So we need to do a rewrite. So when I rewrite it, it's going to be 4 to the power of 2 equals x squared minus 6x. 16 equals x squared minus 6x. All right, go ahead and factor that down.
How do we get to the 4 squared?
So you gotta do a rewrite. So going back to what we learned last week, this is the base, this is your exponent, this is the answer. 4 to the power of 2 equals the answer. Base, answer, exponent. So let's go ahead and factor that down and see if we get 2 answers that will work. And to know if it works, we just need to see if this bubble is positive when you substitute it back in. All right, so what are our numbers that multiply to give you a negative 16 but add to negative 6? Negative 8 and 2, which means my 2 possible answers are 8 and negative 2. So let's check them both. Put an 8 right here. If you need to, pick up your calculator. Type in 8 squared minus 6 times 8 and just tell me it has to be positive. It can't be 0. It has to be a positive number. So if you take 8 squared minus 6 times 8, do you get a positive number?
Yeah.
All right, so that means we can keep it. Now do the next one. Type in negative 2 squared minus 6 times negative 2. They both work? Who agrees that they both work? So then that has 2 answers. All right, just a couple more and then we will end for today. Yes. Yeah, we gotta test them both. And now if you put a negative in your calculator, I hope that nobody is typing it in like this. In this point in the semester, if you all don't know anything, please know that you have to put a negative in parentheses. You have to do that. Like it's a big, I tutor a lot. I used to tutor, I don't have time anymore. Students in college who literally would fail a test because they forgot that important thing. Put the negative in parentheses every single time. All right, last 2. Go ahead and copy these down and then we'll be finished for today. Nope. All right, so we have this 2 that's being multiplied by the log. There's 2 different ways we could solve this. We could either divide it out or move the 2 and make it an exponent. You get the same answer either way. So let's just divide it out. And that gives us log base 7 of negative 2x equals 0 divided by 2, which is 0. Now you need to do a rewrite. So it would be 7 to the power of what? 0 equals negative 2x. Now any number to the power of 0 equals what? 1 equals negative 2x. And then my last step would be to do what? So does x equal negative? So x equals negative 1/2. Go ahead and make sure that we can keep it. If I put that negative 1/2 in that green bubble, are we okay?
Yes.
All right, so we can keep it. That's my answer. All right, last one. What is the base of a natural log?
E.
E. So I'm going to write this as E to the power of 4 equals 5x plus 1.
Oh, isn't e to the fourth number?
E to the fourth is a number. So now we're going to subtract the 1. E to the fourth minus 1 equals 5x. And then we're dividing by 5. So on the SAT, ACT, you can leave it this way. E to the fourth minus 1 over 5. But if they ask you for the number rounded to the thousands place, you need to type it in the calculator. So let's go ahead and type it in. And we're going to do to the thousands place. So that would be 720 or 72 because that 19 rounds up to a 20. Now, if you put this in the calculator, we got about a 10. If you take 5 times 10 plus 1, is that a positive number? Thumbs up or thumbs down? Is it positive? Thumbs up if it works? Yeah, you always got to check it. So I just rounded it to 10. I mean, you know, you could type it in 5 times 10.72 plus 1, but I just rounded it to 10, or you can round it to 11. It does work, so that would be our final answer. Okay, we're going to end there. Tomorrow we're going to do some harder equations that involve properties in order to solve it.